Hello and welcome. I'm Dom Hale for Mining Magazine. Today I'm joined by Adam Burley, CEO of Nuton. He is here to discuss how Nuton's BioLeach technologies are helping reshape copper production for lower environmental impact and to support the energy transition. Adam, it's great to have you here.
Great to be here. Thanks a lot, Dominic.
Adam, can you start by explaining what Nuton is and what you and the team have been working on since launch in 2022?
Absolutely, yeah, happy to. So Nuton's an innovative technology venture of Rio Tinto. We're focused on growing Rio Tinto's copper business by bringing new copper to market using novel, low-impact bio-leaching technology. So we launched the venture about 3 years ago. On one hand, we've been scaling the technology and ensuring its commercial readiness, and then in parallel to that, we've been securing partnerships with copper resource holders, where we can deploy the technology at scale.
Well, thanks for that, Adam. That's a great overview of where Nuton began and what's driven the journey so far. Can you tell me a bit more about scaling the technology? What have been the biggest learnings or challenges in scaling and building a commercial product?
Well, the core of the technology was subject to many years of lab-based R&D and test work. And what we've done with Nuton recently is build off that strong science foundation and bring it to life in the real world. So we've worked a lot on design, so that's engineering for a continuous process at scale that can be safely and efficiently operated and maintained. We've also focused a lot on delivery. So our business model is not to operate the technology ourselves, instead to support our partners, the site owners, to operate. So we've worked on how we successfully deploy that technology to our partners, how we ensure them to be operationally ready, how we support those operators with performance optimization, things like that. And our main technology scaling partner right now is Gunnison Copper at their Johnson Camp mine in Arizona. So speed to market has been a key driver for us at Nuton, and Gunnison offered us a site with installed solvent extraction electrowinning capacity. They had a permit-ready site for a leach pad, an existing open pit with copper resources ready for extraction, and crucially, a willing counterparty ready to invest in a partnership. And so Gunnison have been great partners for us. At Johnson Camp, we're now deploying Nuton technology at industrial scale. In total, we expect to process around 5 million tons of ore, and that's at a design rate of around 280 tons per hour, so quite substantial. Together with our partners, we've gone from concept to cathode in less than 2 years. We're producing copper today using conventional run-of-mine leaching, and we're in the process of commissioning the Nuton circuit ahead of first Nuton copper in the coming weeks. So it's a really exciting time for Nuton, bringing that technology to market for the first time. We consciously chose to limit the study scope, recognizing that with a new technology, it's impossible to study out uncertainty. So we really are learning by doing, really getting sort of stuck into it with a very capable team that can overcome challenges as they arise. So we've learned a lot. We can continue to learn more as we finalize commissioning, the ramp up, and then optimize the performance. As an example, to date, we've captured more than 100 learnings, and we intend to crystallize those learnings into our commercial scale technology package that we then intend to deploy across the partnership portfolio.
Well, look, it's really interesting to hear how those lessons are shaping the next phase. Of course, partnerships are also a big part of Nuton's model, helping bring that technology to life in the field. Can you describe the partnership portfolio and how that fits into Nuton's commercialization journey?
So the market potential of Nuton is very substantial. There's a range of potential use cases, and we're focused primarily on the processing those primary copper sulfides, so the most abundant copper mineral which is remaining in global resources. And those use cases range from greenfield applications, where Nuton would be an alternative to a concentrator. Our partnership with McEwen Copper, for instance, down in Los Azules, Argentina, is a good example of that. There's also a use case in brownfield expansions where we can extend a mine's life using existing infrastructure, as the oxide ore potentially is depleted, or in hybrid with a concentrator such as at Escondida, for example. And then there's also a use case around legacy mine sites where low-grade copper resources remain, such as at Yerington, one of our portfolio partnerships there. So we've really been building out that partnership portfolio, collaboratively assessing the performance of Nuton via test work and modeling, and estimating the value add and the environmental impact of the technology. Our intention is to offer a standard commercial scale technology package. So that's where the bulk of engineering and equipment is defined. And that offers sufficient operating flexibility then to tailor the conditions to specific ore types. Our view is that standardizing that technology package, our sort of Lego brick as I refer to it, will enable us to deploy the technology faster, more efficiently, and offer a product that we can really confidently stand behind.
Well, look, that really highlights the collaborative approach you're taking. Now, for those who might not be entirely familiar with the technical side, let's take a closer look at what makes Nuton's process so unique. In a nutshell, then, Adam, can you explain how Nuton's elevated temperature bioheap leaching technology works and what key breakthroughs have enabled recoveries of up to 85% from primary sulfide ores?
Under ambient conditions, chalcopyrite, which is a common primary sulfide copper mineral, forms a so-called passivation layer that inhibits leaching. The Nuton's process operates at an elevated temperature, which helps to overcome that barrier. So we generate and control heat within the heap using bacterial oxidation reactions, and have developed catalytic chemical additives that further reduce passivation. But I think the main breakthrough really comes in acknowledging that it's an integrated system-wide approach, which is absolutely crucial. So there's no single silver bullet, no sort of single chemical additive. Even the bacteria in isolation won't prosper if left alone. So it's really bringing all the components together across engineering, across science, and data that drives that superior performance.
Well, look, it's remarkable technology, and it's clear that sustainability is built in from the ground up. So, how does Nuton deliver positive impact at its deployment sites, particularly across its pillars of water, energy, land, materials, and society?
Well, we're absolutely determined to produce the world's lowest impact copper. And based on our generic flow sheet, we expect to reduce water requirements by up to 80% and up to 60% reduction for carbon emissions compared to incumbent technologies, being concentrator and smelter as an example. But also there's no need for tailings dams, and the copper that Nuton produces is a cathode, a finished product directly at the mine site. So that doesn't require any shipping, transportation of concentrate to the smelter. So inherently, the leach process is a lot more sustainable. But we also need to understand the specifics of the site, which can vary significantly. So to do that, we establish site-specific baselines to measure the environmental and social performance, and then use live data to validate and optimize the models before we commence operations. So together with our partners, we identify the most relevant positive impact pillar, whether it's water, energy, land, or society, and then embed our objectives around positive impact and that pillar into our commercial agreements.
Well, that is an inspiring framework, and it really speaks to the broader transformation taking place across the industry. So, looking ahead, where do you see the biggest opportunities and barriers for adoption of Nuton's bioleach technologies globally? And what is your roadmap for harnessing and overcoming these?
Yeah. Well, I think the opportunities are enormous. I mean, in most cases that we've reviewed, we're seeing a lower capital intensity, lower operating costs, and that lighter environmental footprint when compared to a concentrator. And then the added advantage, of course, of producing that finished copper product in country is also attractive. But I think the way we deliver our technology via engagement with our partners is really key to capturing that market. We've designed a workflow to evaluate and predict the performance of the technology and the associated business case. And we're also building out that standardized Lego brick of the technology package of engineering and equipment. So there's a lot that we're doing in that space. There's much more to do, of course, particularly in the data and analytics space, and how we confidently predict performance, how we optimize the performance. So plenty of opportunities out there, lots of room for improvement, lots of room for further optimization over time. I think compression of the period evaluation, for instance, via modeling, via data analytics is a key area that we're working on.
Well, Adam, that's all we have time for. Thank you for giving us such a clear view of how Nuton is pushing the boundaries of sustainable copper production. I've been speaking with Adam Burley, CEO of Nuton. I'm Dom Hale. Thanks for watching.